Hi everyone, welcome back. Welcome to this video lecture. My name is Ani Bulai. In the previous video, we have discussed the linear search algorithm and we showed how the linear search algorithm works. In this video, we will analyze the linear search algorithm and we will write Python code for the linear search algorithm. Let's recap what linear search is. Linear search is a simple search algorithm for finding a particular element in a list. Linear search is efficient for small lists and it belongs to the brute force strategy. This is what we have seen in the previous video. Now consider the following list with the following values. This is a list with 8 elements, so n is equal to 8. The index is from 0 to 7. Now suppose we want to search for 89. So our search key is 89. And of course you can choose any other variable than key. But in this example we use the variable key for the number we want to search. So we want to search for 89 in this list and we want to see whether it is present in the list or not. So we have two cases here. The element is present in the list or the element is not present in the list. When the element is present, we want to know the location. So the algorithm, that means the program, should return the location. In our case, we are looking for number 89. So this is at index number 2. This is the third position. So we can have the algorithm return either the index number or the position. Both are right. In the second case, when the element is not present, you want the program or the algorithm to return the element is not found. As we have demonstrated in our previous video, the linear search algorithm checks each element in the list one by one until the desired element, this is the search key, is found. When the element is found, the algorithm stops with searching and returns the location of the element. This is the first case in our example. In the second case, the key is not present in the list. So the algorithm stops also when the list is exhausted. So we have two stop conditions here. One, when the element is found. In our case, the algorithm stops then at index number 2. This is the third position in the list. And the second case is when the element is not found. So the element is not present in the list. That means that the algorithm stops at the end of the list. And in our case, that is at index number 7. Well, here is the pseudocode for the linear search algorithm. The linear search algorithm checks each element in the list one by one until the desired element is found. When the element is found, then the algorithm returns the location or the index number of the element and stops with searching. The algorithm stops also when the list is exhausted. To code the linear search algorithm, we first define a function in line 1. We call the function linear search. We use a for loop to go over the list and pass two parameters to the function. A parameter mylist for the list or the array and a parameter key for the search key. The for loop starts at index number 0 and will go to the end of the list. So in our case it will go till n. N is the length of the list. So we can write n equals the length of my list in line 2. In line 4, we write a for loop with a variable I which goes from index number 0 to n. Now for case 1, we want the algorithm to print that the element is found if the number we are looking for is found. In line 5, we check whether the number in the list is equal to the key we are looking for. And in line 6, we print that the algorithm has found the key at some index number. In the second case, the element is not found. So we want the algorithm to print not found. In the second case, the loop should go to the end of the list. So the for loop should go up to index number 7. The length of the list is n. In this example, n is 8. So the index number of the last element is n minus 1. So in line 8, we check whether I is equal to n minus 1. If I equals to n minus 1, we print in line 9, element is not found. In the lines 12 and 13, we give an example to test the code. And in line 16, we call the function. Now look at the code. What happens when the key we are looking for is found? Pause the video for a moment to check this. As you might have seen, the algorithm continues for searching after it has found the key. Did you see this? Well, when we have found the key, which is 89 in this example, the algorithm continues with index number 3, 4 to index number 7 to search for number 89. Now, what is the point to search after finding the key? What we should is to put a break in line 7. This stops the algorithm when it has found the key. So, now you can call the function anytime when you need it. If we look at the time complexity of linear search, we see that for the best case, the algorithm needs only one comparison to search the key element in a list with an element. The best case occurs when the key element is at the first position of the list. Suppose we would search for 46, then the algorithm would just need one comparison. So the time complexity for the best case is of the order 1. In the worst case, the algorithm needs n comparison. This is the case when the key element is either at the last position or it is not present in the list. The time complexity for the average case is calculated as follows. For the average case, we divide the sum of all the cases by the number of cases. So if the key is at index number 0, we just need one comparison to find the key. That is just one case. The second case is that the key is present at index number 1. Now we need two comparisons to find the key. When the key is at index number 2, we need 3 comparisons. If the key is at the end of the list, we need n comparisons. So we have the sum of 1 plus 2 plus 3 to n. And we have n cases, so we divide by n. Recall that the sum of 1 plus 2 plus 3 to n is n times n plus 1 divided by 2. When we fill this in equation 1, we get equation 2. So we have n plus 1 over 2 comparisons. Then the big O for the average case is in the order of n, since n will dominate as n becomes large. So we can ignore the other terms. Well, this is all about linear search. In this video, we wrote a code in Python for the linear search algorithm, and we discussed the time complexity of linear search. Well, that's it for now. Thank you for watching, and I'll see you in the next video.